Isip na yun, Hub.
Hi there! Welcome to the first episode of our series on limits. In this presentation, I will give a very brief introduction to what we mean by limits.
But before we continue, do not forget to like this video, hit the subscription and notification bell to stay updated of future videos.
First, we consider a function here as our working example. We have a rational function f of x equal to x minus 1 all over x squared minus 1. Now, we start by realizing that this function has values at the majority of x values or numbers in our x-axis that we can identify. For instance, we could evaluate it at x equal to 2 if we want. What's the value of this function at x equal to 2? That means f of 2. This is just the same as 2 minus 1. We substitute 2 to our function here. We have 2 minus 1, the square of 2 minus 1. We would have 1 over, that's 4. 2 squared is 4 minus 1, that is 3 or 1/3. If we want to evaluate the same function at different x value, say 0, we would compute 0 minus 1 all over 0 squared minus 1. We would have negative 1 over negative 1, that is positive 1. Or, let's try a negative fraction. We have negative 1/2. Substituting negative 1/2, we would have negative 1/2 minus 1 over negative 1/2, the square minus 1. Negative 1/2 minus 1 is just negative 3/2. The square of negative 1/2 is 1/4 minus 1. So that we have negative 3/2 all over 1/4 minus 1, we have negative 3/4. Simplifying it further, we would have positive 2. To have a visual idea of what our function is, let us try to graph f of x using these values that we computed. So as an ordered pair, this is actually the same as 2, 1/3. Because our x value is 2 and the computed f of x or y value is 1/3. Also, for this case, our point here is 0, 1, and then the other one, we have negative 1/2 and positive 2. Let us reduce first the size of this one. Let us now build our Partition plane. Let us plot. We start with 2 and 1/3. It's 2 and 1/3. Maybe that point is here, somewhere here. And then we have 0 and 1, 0 and 1. And then negative 1/2. That's negative 1/2 and 2. There. The 3 points that we computed. Joining the points, it seems that f of x looks like this. So that is the graph of f of x. Now, let us continue evaluating the function, but this time at x equal to 1. What happens to f of x if x is equal to 1? Let us compute. We have f of 1 is equal to 1 minus 1. I'm substituting it to the function. And then we have 1 squared minus 1. We have 0 over 0. And again, 0 over 0 is not really a number. This is an indeterminate form. So f of x at x equal to 1 is indeterminate. Now, what does that imply in our graph? So our graph is actually a bit wrong because we did not consider the fact that the function f of x do not have a value at this particular x value at x equal to 1. Now, to correct our graph, we have to put a hole in the part of the graph that is aligned at x equal to 1. Putting a hole here would indicate that the function that we have here does not have a value at that particular point only at x equal to 1. Let us go ahead and do that. Draw a hole. There we have it, our hole. Now, we cannot do anything about the fact that this function is indeterminate at x is equal to 1. What we can do instead is to explore the function not at x equal to 1 because we know already that it's indeterminate, but explore the function. What happens to the function around x equal to 1? So this is how we're going to do it. We're going to identify numbers that are close to 1 from either its left and right, and then solve for the value of the function. For instance, if I'm going to identify a number that is close to it, maybe I'm going to identify 1.1. What is the value of the function at x equal to 1.1? I can even make this closer to 1 by making it 1.01 maybe. From the left also, we can have 0.9. If we want to make it closer, we can identify 0.99 or 0.999. Those x values, we're going to evaluate the function. So what is the value of the function at those values that are not equal to 1, but they are close to 1? Let me organize first our space here. Okay, let us identify values that are close to 1. So if this is 1, from the left side, we are coming from here, from the left side of 1, we may say 0.9, 0.99, and 0.999. From its right side, we may say a number that is close to it, to 1, is 1.1. An even closer number is 1.01. or 1.001. Now let us evaluate the function at these values. To make our job easier, let us make use of a calculator to do that. Let me first show you how. So the first thing we do is to input our function. We have x minus 1 all over x squared minus 1. Since it is a fraction, we have to make use of this button there. And then for variables involving x, we can press alpha in this button here. It's here, we see x. So alpha x, it will input x minus 1. To place the cursor in the denominator, we have x. This time it has to be squared, so we press that button, minus 1. After inputting our function, we can make use of this function, this button here, calc, C-A-L-C, to compute that function at any x values that we want. So if we press calc, it would ask us which x value are we trying to evaluate that expression. So we start with 0.9, so we input 0.9, press equal sign, and then we would have 0.5263. Let us write that first. Let us do the same for the other values. So we go back to our calculator, press the left arrow, it will go back to our expression, and then do the same, press calc, and then this time we are computing for 0.99, so 0.99. Let's memorize the answer, 0.5025 approximately. Repeat the process for 0.999, 0.50025. We do the same for x equal to 1.1. So we have 0.4762. We have 1.01. That gives us 0.4975. And lastly, for 1.001. We have 0.4996. Correct? 0.4996. Okay, we are now done. Of course, at x equal to 1, this is indeterminate, but we are not exploring at x equal to 1. We are exploring at x near 1. Now, what happens here? What happens to our function if the x values are not exactly equal to 1 but are just close to it? So we say that x is approaching 1 from the left side of it. 0.9, it's increasing, it's becoming closer and closer to 1. What happens to f of x? Also, what happens if x is approaching 1 from the right side of it? What happens to f of x? Is it also approaching a particular number? In our case, yes. These numbers here seems to be approaching 1/2 or 0.5. Also, from the right side, it seems that these numbers are getting closer and closer to 1/2 or 0.5. This number here, 1/2, is termed in mathematics as the limit of function f of x as x approaches 1. It is 1/2. The most important part of this limit concept is that we do not really care at what happens to the function at exactly x equal to 1. That is because we already know that it's indeterminate. We cannot do anything about that. What we are trying to say here is that f of x is behaving something if we choose x values that are close to x equal to 1. It is approaching a particular number. That number, this number 1/2, is called the limit of that function as x approaches 1. That is our introduction for limits. Kindly click on the link above for the continuation of our presentation.